Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In the previous videos, we gave the intuition that in the level model, the beta 1 is the change in y when x increases by 1 unit. And in a level model, this effect is constant. Now we'll show that mathematically step by step. And the way we'll do that is by starting with the actual population model. So we were looking into the simple regression and we had y equals to beta 0, beta 1, x plus a error term u in here. Keep in mind that in order for us to be able to trust that interpretation and to have that interpretation, we need key assumptions that we have already extensively talked about for OLS. And the one that we're going to look in here is the, most of all, the conditional expectation in here being equal to 0. So this is the assumption that makes the regression line represent the conditional expectation function. Okay, so that means that if we were to take the expectation of the expressions that we have on both sides on x, then what we're going to see is that the expectation of y on x is equal to the expectation of beta 0 plus beta 1 x plus u, all of these conditional on x. By using linearity of expectation of the expectation operator. And keep in mind, there is a video entirely dedicated of the linearity idea of the expectation operator. Then we can rewrite this expression now as the conditional expectation of y on x being equal to the expectation of beta null plus the expectation of beta 1x plus and sorry, it's all conditional, so let me just add this. And ultimately, the expectation of u on x. Now, the conditional expectation of beta null on x, keep in mind the beta null is just a constant, so that is just going to be beta null. And for the beta 1, it's very clear, beta 1x, it's very clear that your conditional expectation is just going to be beta 1x. The only bit that we are left to deal with is the conditional expectation of the error term on x, which we already set out from the beginning that we absolutely need that for us to do the interpretation in terms of conditional expectation functions. So this is going to be 0. Which means that now we have that the conditional expectation of y on x is just beta 0 plus beta 1x. So this is the regression line in the population, and it's like the conditional mean of y given x. Now, what about the marginal effect is the derivative? If you remember, we said and we showed graphically how the slope was always constant, which means that when we looked at any changes of x from 1 to 2 or 3 to 4 or 10 to 11, the slope being 2 meant that the effect, so you changing your x by simply 1 unit, was literally your slope. So let's look into the marginal effect of x on the conditional mean of y. And that is going to be the derivative on the expectation of y conditional on x with respect to x. Which means that the same thing you're going to apply to this rest of expectation, because now you know that the expectation of y on x is the beta 0 plus beta 1. So it means you're finding the derivative with respect to x for beta 0 plus beta 1x. And clearly the derivative of this entire expression with respect to x is simply beta 1. Okay, so this entire proof of the interpretation, so the slope coefficient, is literally the derivative of the conditional mean with respect to x, which brings us all over again, like, then does it make sense based on what we know right now that the effect is constant? Well, yeah, because look, in front of the x, you always have the beta 1. So that derivative is going to be always beta 1. And we know when we have estimated the beta 1 as a beta 1 hat, then it's just like a number, a constant. And it's not going to depend on x. That's what makes it constant, okay? So in here, we didn't find this times x. It was just beta 1 by itself. So that means that the marginal effect is going to be the same at every x. All right, and that's why the model is called linear and the slope doesn't change. So key takeaways for this case is that the slope is the marginal effect, and the marginal effect is constant because it does not depend on x. In the next video, we'll do a concrete numerical example so that you can see like the units and the interpretation, so it doesn't just feel completely automatic, but you see the context. So stay tuned and I'll see you in the next video.